All right.
All
Looks
you.
like it's recording. Okay.
Is it working?
I
Yes.
think so. Can you see my screen?
Yes.
All right. So, hi, everyone. Thanks for joining. My name is Tal. As Dan said, I'm based in Italy, so it's exactly midnight now. So, I'm stayed awake, especially for you. All right. So, we're going to talk about cloud native security testing. I'll emphasize a little bit more about serverless because it's an abstraction of cloud native, and things are clearer on that aspect. And I want to try and let you understand. I don't know if you've been struggling with testing cloud native or serverless application with what there is today, um, but I think there is a new approach that should be taken. So just a little bit about me. I'm coming from the AppSec world. I've been doing application security for about 15 years. Um, as Dan mentioned, I had quite an interesting couple of years. So I've been in startups, enterprises, consulting, but recently I joined a startup called Protego Labs. That was 2 years ago. I led the security research. We built a serverless security protection a solution, and we got acquired by Checkpoint um, a little bit more than a year ago, so about like 13, 14 months ago. After the acquisition, I started thinking what should be the next step for enterprises who practice or develop in cloud native environments. So in Protego, we did runtime protection, instrumented the environment, and then incoming attacks, we would stop them um, potentially. I thought, what's the next step? Where should we take it to down or further left to the developer? And I founded, after a couple of months, I founded Cloud Essence. You probably haven't heard of it, and you probably won't because we got acquired uh, 2 months ago, a little bit less than 2 months ago by Contrast Security. And our solution is going to be integrated into their entire application security testing platform. And we're going to build an R&D in Israel, where the original company was. So you can find me on GitHub, Twitter, LinkedIn. I'm also teaching at the Quinnipiac University in Connecticut, a couple of application security courses at their part of their cybersecurity master's program. So if you're interested, shoot me an email. All right. So we're at the CSA, so I probably don't need to preach you, but it's been quite known that the development of new application or just development is moving to the cloud. IDC already predict that 70% of newly developed application or enterprise application will be developed in cloud native by 2021, which is today. So happy 21, happy 2021 to everyone. Uh, I know you understand that their cloud native or the cloud transformation has begun. This is not what I'm trying to say here. So, yes, there are cloud-born companies or full-blown cloud companies like Netflix or iRobot or Skyscanner or Via or companies like that. Yes, those companies built their cloud development or cloud environments or cloud product based product early on in the process, so they probably already have some of their security processes in place, and they have the budget for that. They also, if you look at GitHub, for example, a lot of those companies like Skyscanner, Netflix, Capital One thing, companies like that released some of their um, security testing tools as open source because they've been doing that for a while. But these are not the interesting part companies that I wanted to talk to you. So the interesting part is the companies on the left, the companies that struggle now because they are trying to move to the cloud. They already have a bunch of workloads, enterprises, and they decided, oh, this new app or this new version of an app or this backend feature or automation, we're going to start experiment, move it to the cloud. The problem there is that because they have already big security budgets, security or long security processes, and they already implemented all those tools today like checkmarks and Veracode and AppScan or HP or even Contrast, those kind of application security solution. So testing solutions. So those companies already have those solution in place, and they have the new team running on serverless or cloud native development, and they tell them, hey, take these licenses we already have. So take these tools. We have this process where we test everything. We do SAST, static analysis on everything. So take check marks and run it on your code. And then it breaks and they suffer. The team suffer because those solution doesn't really fit their needs. And that happens because of a couple of things, which we will discuss today. So first, it's important to understand that cloud native development, it's not just a development button. Cloud native is a different architecture, right? So you don't have one big flow monolith application. You have a lot of different resources and services connected together by configurations and infrastructure. So when you look at that, or when tools, let's say traditional tools, look at this image, they don't understand it the same they understand it just looks like a lot of moving parts unrelated to another because the solutions or the tools that the task for security, they don't understand cloud, they don't understand the infrastructure. So for them it looks like a lot of small pieces. The cycles are different, right? Instead of waterfalls or even like the agile processes, we have DevOps, DevSecOps. Everything is automated. Everything is a continuous CI/CD, continuous integration, continuous deployment. Everything is continue goes from development to production. There is no slow process when you now down uh, take down the server and update everything. You probably know that. I don't need to tell you all about it, to preach about that. So, but also the decisions, also the security decisions are being taken bottom up, not top down. So it's not like the manager needs to build the feature, is doing the entire review, requirements, design, and then bring it down to the development and tell them uh, this is what you need to do. Developers take more responsibility. That means also for security. So they decide what they need to do. They decide on what, even on what languages they can. We, for example, we have developers that like to develop in Go. So their code can be in Go. Other developers like to do Python, like me. So we write in Python and they can work hand in hand because everything runs on a singular infrastructure. So developer can take decisions, technology decisions. They pick up open source, they pick up configurations, they pick up everything and build it uh, and make the decision by themselves. So it's a different perspective. Okay, so how does a serverless app looks like? This is quite a complex one, I guess. It's not like super complex. It's not too big, but it looks like it. It looks like a lot of small pieces tied together with some arrows. Those arrows are events and are configurations. So that means that when you look at this app, it doesn't look the same as you would have a one big server with a lot of files. These are different sources. They can live in different places. And the only thing that ties them together is some kind of a configuration that you did, or a service that connect them. Now, the service can be uh, an AWS service like here. So if you have, for example, a flow that starts with a code, writes it into the database, and then another code picks it from there, and you want to test that scenario, there is no tool that at the moment that can understand that flow, because the database is not a service or a resource that they can interact with. So it's just a lot of resources. Okay, uh, the, let's go a little bit deeper into what serverless is. So cloud native is basically anything that you build on the cloud, on containers or managed containers. So you don't own it, you just use it as a service usually. Um, you can't have it as a server, you can't deploy anything on a server. You can run your app or your container inside. It can be servers, but it's not one managed server. So serverless is even more of an abstraction for that. So what is serverless? Serverless is a container, but it's not your container. It's the cloud's container. And that means that whenever your code needs to run, and what's needs, we'll talk about it in a second, the cloud provider spins up a container, which you don't have access to. You cannot SSH to it. You can't go inside. It spins up a container with the required runtime. So if it's Python, then Python, and runs your code, and then shut it down. Um, the way that it happens is then when what you configured before, what is the event that should trigger your code or run your container or run that container. So you configure before, I want my code to run every time someone sends me an email, or every time that someone uploads a file, or every Tuesday at noon. And you configure that. And when that event happens, that container comes up and runs your code. The environment inside that container is read-only. You can run except from /temp if you're on AWS. If you're on GCP, you have /temp and home. And if you're in Azure, you have /temp and op or www. I don't remember exactly. I did a little bit more research on the differentiation of them on Black Hat Europe 2019. You are more than welcome to look at that. And then the code runs and it terminates. There, as I said, there is no connection to the internet for the container itself. The data is temporary, so when the container or the code finish to run, it just it's being shut down or being terminated, unless, and we'll get into that, unless someone or a new event comes and then the cloud recycles your environment without letting you know, but they recycle it. And the code lives inside that environment. That is interesting for security reasons, and we'll get to that. And also the keys, and the keys means the permission of that resource, and we'll get to that, also are in the environment. Okay, so we talked about serverless, but what about serverless security? So I'm going here to Google Trends, and I did a Google trend on serverless computing topic, and you can see that in the past 5 years there is a constant increase in requests. The last part is a little bit fuzzy always, but when I want to compare it to serverless security, so how many or how much people are looking at serverless security, I get none. So that's constant zero until I started dealing with it on late 2017 or uh, so that one is probably me. Sometimes there is another guy or girl that is doing that, but that's constant. So it's between 0 to 2 for 5 years. And that's a little bit surprising because I thought that we will pick it up sometime, but no. So, but why is that? So my initial thoughts were, hey, maybe people think it's exactly the same, so they don't care about it. They think they have it all figured out. Um, so is it the same? It's not really exactly the same. There are a lot of things that are similar, but we'll talk into that and we'll see that. So, sorry. Let's talk about what are the challenges in serverless and cloud native environments, mostly serverless here, but we'll talk about touch some cloud native generic topics. What are the challenges? So the first challenge when you go to AWS or cloud is how do you manage the identity and access management? It's called IAM on AWS. Most examples are on AWS, but they apply for all cloud providers. And the problem is for AWS, for example, there are 7,000 different actions that you can choose for your code. So how do you deal with selecting that? So let's see that code. It's just a simple code that receives an event and a data and writes it into the database. Sorry, if you look at this line, is doing put item and writes the item into a DynamoDB table. DynamoDB is a NoSQL database, key value. All right, so you have that code and you tell your developer, hey, I need, of course, you can't run without it, so you need to find the proper permission. The developer thinks, I need this code to run, hence I need something that works. So he goes to Stack Overflow or to the AWS documentation, picks up what he needs and uses that. So the permission would be DynamoDB wildcard and resources wildcard. So that doesn't really match. So the put item is writing a single entry into the database, and the DynamoDB wildcard means that the code, even though it doesn't, can do whatever it wants. It can delete tables, it can create tables, it can change the policy, it can write multiple items, it can delete, update, whatever it needs. But not only that, it can do it to any table within the cloud. So even if it's a different environment, different application, it can still do it. So it probably won't because the code doesn't do it. But if there is a problem in the code, that might be a problem. So a better solution, of course, would be this. DynamoDB put item on this specific item. That means that the code is limited to that specific action on that specific resource. And even if there is an attack going on, they won't be able to do that because the cloud will stop them. So let's see how it looks. Just a second. Right. Stop, demo time. Let's see. Okay, so I just have an API here, right? It's part of a vulnerable app. So we'll discuss that later. So I can use API AWS API to scan the table, right? I just ran AWS CLI command that scans the table. Now what I'm going to do is I'm going to look at the permission of the code that deals with the database, and I can see that same as the example, DynamoDB wildcard on any table. And all I need to do is I'm going to change it to the actual or the required resource. I save that. And now, if I'll run the same thing, I'll get an error. So I'm not authorized to perform scan on this specific resource. And now I'll also limit the action from wildcard to get item. And then I'll run it again, the first one. It works. And then I'm unable to do scan, right? Even though the database is okay, because the cloud now blocked me because I reconfigured it. So why am I telling you all that? Well, because it's a nice it's a nice way to go. So you need to limit all the permission. Think about it. If you look at the monolith application and you think about it like this, it's I have a couple of lines of code that I want them only to write to the database. Then I have another couple of lines of code that I just want to read from the database. And then this part of the code can write to the logs. This is imaginary and crazy for monoliths, but it's possible for serverless. The only problem is scale. How do you do that when you have a lot of changes going on? The next part, so this is the first one. So the next challenge is loss of perimeter. Monolith application, we always had one way in, right? We had the entry to the application would have been a load balancer, an API gateway, whatever it is. But it's always one way in. So we had a TCP or usually just HTTP, even HTTPS, right? Request going in, doing the flow, comes out as a response. This is monolith, synchronous. And even if not, it's a request and then polling or whatever it is, but there is always one entry perimeter. So what we would do is we take all the security defense and put it there. So we'll have firewalls and IPS, IDS, DLPs, whatever it is on that point, but we don't have it anymore, or at least we don't exactly have it. So first, we don't have a server, so we cannot deploy a lot of the security solutions that we had before. And second, it's not only APIs now. You can run code from analytics, from files, from emails, from notification services, from IoT. I showed on Black Hat how I can do SQL injection with my voice talking to an Alexa device, because that Alexa device then talked with a serverless function. There is no server between the Alexa device and your code. Well, there is, it's just not yours. It's AWS server. Okay, so let's see how we're doing an attack through an email. So the user sent an email, and this email triggers an event that runs our code. The code fetches the attachment from the cloud storage, process it, and then returns an email, right? And I showed this on DEF CON, so you might see the logo there. So DEF CON, call for papers, and I wanted to submit, it's not real, but I wanted to submit a paper to DEF CON. So I submitted a talk And you'll be able to see that in a second I got a reply, automatic reply, right? Thank you for your submission. We got your email, and we will notify you. Now, now I tried to send a malicious file. So I thought, hey, if they're automatically processing PDF file, I can send an evil PDF or a malware. So sent the email. That's not the interesting part yet, but yeah, I got thank you. Only this time, they said, sorry, we identified. How can you stop it? Okay. Right, we identified a malicious file, and you can click on it, and it will go into VirusTotal and with all the file, the information. So I thought, hey, if they're running some scanning on that file, maybe I can do something nice. So I wrote an exploit. Again, it's not real. Everything is imaginary. That the payload will, let me go back. Okay, so the payload of this exploit will run some AWS code. So Python code, which interacts with the AWS environment infrastructure. So you can see here, Bodo3 send email. So I'll send an email, and then this email will say, hey, congratulations, you've been accepted. But then what I'll do, and this is the nice part, I'll go to the bucket, or the code will go to the bucket where all the submissions are, and will change its permission to be public. From that moment on, I can access, or anyone can access, all the submissions on the server, on the storage. Sorry, it's not a server. And then I took this, zipped or archived it, then I uploaded it to some kind of a host, and then I have this file, which is not a PDF anymore, but it's a PDF with a different file name. It can also end with PDF. It doesn't matter. Just a second. Okay. Okay. So now you can see that this is the bucket or the storage that holds all the submissions, and it's private. So I get access denied. Now I'm going to go through the entire process again. I'm going to submit my malicious file. Now, the Lambda, as I showed you in the diagram, is vulnerable to code command injection. So you can see here, I just submitted myself some notification along the way that I'll know things really happened, and the code was vulnerable, downloaded my payload and executed it. So I got the thank you, but I also got a fake email, which I sent to myself, obviously, which says, hey, congratulations, your token was accepted, and you click here on frictionless.com to get your $1,000 honorarium. But the nicest part is that, and this came from the real server, because I used their credentials, their account. I just sent my own code. And the nice part is that now this bucket, which was private, is now entirely public. So I can get all the submissions of everyone. And I did that because the APIs, or the cloud, is open to anyone as long as you have the right permissions. So it's not like your own servers running localhost with your own proprietary code, and you don't know how to interact with them, or you can try, but the cloud is open for everyone. You know what to do. You just need to have the right permissions. All right. So serverless risks. So I have event injection, which is basically any type of injections that you know, but they are coming from events. Events because your code runs based on events that comes from AWS. So it's a little bit different. Broken authentication. Serverless is stateless, so you don't have a session throughout your entire cloud workload. So when you run, you have different resources, and I showed you the picture with a lot of resources. You have to take care of authentication on every point because there is no session going on between them. They are completely stateless. So a container comes, spins up, runs your code. It doesn't have any idea of what happened before. Sensitive data exposure. We talked about keys in the environment and uh, source code in the environment, and of course, data in your cloud. Over privileged functions, which is what we saw earlier, vulnerable dependencies. That's not new. Insufficient logging and monitoring. So again, it's not new, but when you use the cloud environment, you don't have the same visibility with the same tools. You have to use, or you have to know what to do in your cloud in order to get the relevant information. So you can't just go into the service or to a log and read the logs now. You need to have some tool or some scripts or some process that will show you relevant information. Uh, Open resources, a huge problem. You've probably heard about a lot of it. I'll show you an example in a second. Denial of wallet versus denial of service. So Lambdas, for example, and other resources, they have limits, hard limits. So for Lambda, you can run 1,000 concurrent resources in your entire account. So if someone runs your, and it's something, let's say your one code or one of your function has an API, an open API, or even a public API, or authenticated, but to anyone. So someone can just call it in continuously with threads from his computer, and you'll get a denial of service. So if you, and sorry, you'll get a denial of wallet in this case, because you'll pay when you use serverless. You pay for based on events. So whenever something happens, you pay. You don't pay if it's idle. You pay when you use it, pay per use. So if someone keeps calling your code, you keep paying. But if you block it, so let's say, hey, I'm limiting my Lambda to only 100, so I'll have enough resources for my entire other account for the entire application, then you're going to get a denial of service. And the last part is insecure shared space. So I told you when the code dies, the container dies, the data dies with it. That's true. But I also mentioned that if in requests or events keep happening on the same environment, then they're going to recycle the container or the environment where your code runs. So if you wrote something to the /temp directory, for example, and another invoke, another event is coming, there might be a recycled container or environment with the same data as in the previous run. So it's going to be, you might be able to access sensitive data there. And secret management, like everywhere. So these are serverless risks, which are considered to be the top concerns at the moment from what we hear from customers, from people talking about it. But we're trying to have a serverless top 10 project. So I opened an OS serverless top 10 project. I know there is also a CSA projects top 12. Both of them are great. The top 12's risks pretty much talk about those. The top 10 tries to get data through an open call from the industry, and will hopefully release it in the next year or so. All right, let's see another demo. So in this case, I'll do a live demo. What can go wrong? The attacker, sorry, just a second. The attacker uploads a file into an S3 bucket or cloud storage. This triggers my Lambda, which is a code, and the attack will make the Lambda send back to me their keys. And with those keys, I'll be able to use to interact with other services. So the reason that I'm going to show you that is because it's very important to know that if you have a vulnerability in one resources, it doesn't end there. It ends where the permissions or the permission of that resources limits you. So if you remember the Capital One breach, very famous, right? The attacker managed to, there was an unpatched firewall. He got into an EC2, talked with an SSRF, got the keys. Now, from that point on, he used those keys to interact with other services like the S3. So let's see that. All right, so I have this DVSA, damn vulnerable application, which I wrote. It's a vulnerable by design application. It's also open source. And one of the features here is sending a feedback where I can also upload files. So I'll upload another attachment, which is going to send somewhere the environment variables. And this somewhere happens to be my computer. Let's see. Yep. And I got this. And now I got this environment variables decoded with base64. So all I need to do is decode those. Then I need to find the interesting part, which is the access key, the secret, and the session. And once I got those, I can interact with the customer's cloud from my own station as if I was the function. So I can do AWS, DynamoDB, list tables. I'll get the entire list of tables in the account, and I can do lateral movement and do DynamoDB scan and table name, orders DB. Let's make it prettier. And then I can see all the orders in the system, the users, their phone numbers, their addresses, and everything from my own computer without getting noticed. Because from the perspective of the application, I'm the function. All right. Okay, so one of the biggest challenges is wrapping everything at scale. So we have a lot of services, frequent deployments with features. We don't understand who's talking to who. And this happens to me. We went to a customer and we told him, hey, let's try this product. And he said, great, I have 200 functions. That's going to be great for us. We installed it, or we onboarded him, and he had 3,000 functions. He didn't really know what's going on because he looked at one part. It's not like you see the entire app. Each one can be in different region, in different area, doing different things. You have many developers with a few AppSec or a few security, and you don't know what's important. And you don't understand if the security is the same. What's the priorities? Who takes care of the security of the infrastructure? So all these is a problem. And when you bring traditional security tools, they're a little problematic. So we talked about it earlier. They're ignorant to the environment. They don't understand the context and relationships between the resources. They don't understand the cloud itself as a service. They're blind to anything that is not an edge. So if you have an Alexa device, like I mentioned, they don't know how to edit. They block developers instead of enabling them, and then they distract the CI/CD, so they don't like it. The development just don't like it. And all those are hard to scale because, as I told you, the developer also owns the security, And when you need to bring the AppSec, that where problems happen. So this is how it looks. You have Mario, the developer, and Luigi, the AppSec, and you have some tasks running. You want to run some security tests in your pipeline. So you push code, and then the AppSec is going to configure some testings, maybe SAST, and then the developer will have to go through that and filter the 1,000 results that he got, if not 5,000. And then he's going to go back to the AppSec and tell him to help him and verify. And then down the line, AppSec will configure other tests, maybe IAST or DAST. I'll have to configure them, and the developer will have to write code coverage, so we'll be able to know what we're testing and to test them. And then the DAST comes, and then AppSec will going to run it separately once a while, and then he's going to talk to the development to see what's important, because he cannot deal with everything. Basically, nothing works. So how do you do test serverless applications? So this is a use case taken from AWS. You have the iRobot Roomba service, registration service, the IoT device, the iRobot talks to an API, which then do some queues and IoTs and writes to the log, and these two code functions reads the log and then feed it up into the IoT or the thing registry, getting the policies and deciding how to act. It's not important what happens, but let's see how we test it. So I'd say maybe easy, maybe SCA, like sneak image scanning, that can work. But well, I think it's important, but it covers maybe 10% of your app, and you're just trying to fix problem that you brought from others. So you don't have anything that can test your code, your services, and your configurations. But it's very important. So the cloud provider usually give it to you as a service, maybe a paid service, maybe an open source project service that you can do, but you don't have to invest all your money in it, because that's not everything that you need. So how about infrastructure as code? There are many companies that come with infrastructure as code, which are good, but because they're very left, right? It's even before you do anything. But that means that also have limited visibility. They just see the infrastructure. They get zero code coverage. They don't have any logic because they look at YAML files. So you don't get good prioritization. And they're usually infrastructure is codependent, like dependent. So some for Terraform, could be for serverless, and that depends. What about Pulumi? What about CDKs? I don't know. All right, so I know the solution. It's easy, IAST, right? Well, IAST is a modern AppSec, right? It instruments into to your server and goes into your actual code flows, so you can get what's actually happening. So it's accurate and reliable, and it enables DevOps. But, and there's a big but here, well, there are no servers to instrument. So there is nowhere to put your IAST, even if you wanted to. So SAST is a solution. Well, okay, so SAST really is known to have false positive in monolith. When you put it into your serverless app, there it doesn't see anything. It sees different type of source codes unconnected, so it doesn't understand the source. What's there is no HTTP here. What's the input? What's the source? There is no sync, because the response is not going out to the client. It doesn't go to the database as it used to. It might go to the database using AWS APIs. So you'll create a client and you'll do a put item or something like that, but that's not a database from SaaS perspective. So basically it doesn't understand what's going on, and you'll get a lot of results which are not really relevant. And if you don't believe me, you can try it. I'm sure that in a lot of, or in some cases, it can work good enough. Dust, maybe dust. So let's see how we do dust here. Well, if there is no request or HTTP, or not response, because many times what happens is you send a request. Let's say here, you send a request. It's not like the iRobot is synchronously now looking for the response and saying, okay, let me wait now before I can start working. It's not working. Like, it just sends a request and it works. Um, so there is no response to look at here. And many times, as just I explained in Alexa, there is no URL, no request, nothing goes in. So you can't even if you wanted to, there is nothing to test here. So I give up. So, and I'm telling all of you, all this to you because this is exactly what I thought before I studied Cloud Essence. Sorry, and then I came up with something, or I thought there is another way to do that. And this is something that should be specifically for the cloud, for cloud development. It should be born in the cloud, should be created for the cloud. And I think it should be continuous and frictionless and complete. So you don't have to have a lot of tools, because the infrastructure, which is the cloud in this case, gives you so many capabilities or opportunities to do that. So the process that I came up with is that you click connect. The click is just saying, hey, you have a cloud, and with one click you can install anything on the cloud if I'll give you the right infrastructure, the right template, or the right cloud formation if it's AWS. So you click, and then I can start working. So there are a lot of services that do that. Not all of them for security. I don't know if you know Absagon or Datadog, around that. You click, you install, you start analyzing your code or your permissions or your libraries or your code. And then you, of course, validate whatever you do, you report everything. And the nice part, you keep monitoring. So if you live in the cloud and someone builds something, you know that you can know that something new happens, and then you can rerun that cycle. So let's see how it looks. Um, so we have Mario as the developer, and Mario writes new code with a new API. In the traditional world, he will build few APIs, Mario and his friends. And every once in a while, they'll go to the security team and they'll say, hey, this is our system. We have 5 new APIs. Please test them. In this case, because you're in the cloud, you can understand that, hey, there is a new API here, and this is the flow. The flow is their API calling a function, uploading a file, calling a function, sending an email. And all these are connected to one another, just not explicitly. It's a configuration thing in the cloud. But again, I'm in the cloud, so I know that. And then what I thought, hey, we can test that for security, the entire flow here. So I can try to call the function or upload files or send emails. And then because I'm already in your cloud, I can also go back to all of those resources and check what I did and see if I did something. So if I try to upload a file, I can look in the storage and see if I managed to upload a file, something that you can't do with fuzzing or coming from the outside. So let's say you find a vulnerable function. Now, as I mentioned before, it's not enough that the function is vulnerable. It's not just the function, it's your cloud that is vulnerable. Just depends what. So what you do is you take out the credentials, look at the cloud and say, hey, with this credential, I can now access this email service, this specific database, and that storage. So the impact is not only the function, but all those sources, resources, and services. Same example here with Alexa. You can't really test it with any tool because no one will understand what's an Alexa. So your only way for testing this scenario is recording yourself seeing stupid things like apostrophe and I don't know, or 1 equals 1. Record all of those and then play it to your echo.device and see what happens. But I don't think it's going to work for you. This is why I built DVSA. It's an open source application, vulnerable by design, that you can test. And actually, you can install it with 3 clicks, as I mentioned. So you just click and you install it, everything, and it just runs. But if you do that, make sure not to put it into a production account or a sensitive account, because you'll have access, you'll give access to those resources to everyone or anyone. So I would call it CAST or something like that. So Cloud Application Security Testing. That means something that is specific for cloud development, which can give you the automate your process for permissions and automate your code through the actual flows in your system. And that's it. I'm hoping to be able to bring this tool to live in a couple of months. But in the meantime, if you want to learn more about serverless and serverless security and serverless attacks and exploits and defense and serverless top 10s, you're more than welcome to go to this URL. I publish all my talks and everything that's available, videos, slides over there. There are plenty more, I think. Before COVID, I managed to do 20 something conferences in 2019. And then COVID hit and I just stayed at home, but I also do conferences from remote. That's it. So thank you very much for listening. And if there are any questions, I'll be happy to answer. Exactly 1 hour.
You mentioned a scenario where data can persist between invocations of a function. Can you recap that? When does that happen under what circumstances?
Yeah. So when the event that should execute your code happens, if I'm talking, I'm giving the example in AWS. AWS spins the container and runs your code, and then it dies. But there is a small period of time, not so small, a few minutes. They don't publish it, but it's around 4 minutes. And within this time period, if another event comes, then instead of bringing a new container or a new environment up, they already have yours waiting. So, or the previous one waiting. So they will recycle it and run the next event in the same environment. And that means that everything that was before is still there, but you can't control it. You cannot control it. So it's not like you say, hey, I know that the next 5 events are going to land on the same environment, so I can keep working. You don't know it. It's random. So, and let's say you have hundreds of events on a, I don't know, a couple of minutes time frame. It's not like you know which event where it will land, but it might, or it probably gonna land on a recycled environment. And unless you explicitly deleted the files in /temp, for example, they're gonna stay there if you wrote something.
So not useful, but also dangerous. Awesome.
It's for performance, right? Yeah, they wanna, because if you run a new environment, it's gonna take, I don't know, on Python, maybe 300 milliseconds. It depends on the environment. Java takes a little bit more, maybe a second or so. But if it's a recycled then event, then you're going to get into 5 milliseconds, or I don't know, 10 milliseconds. So
they leave it in the file system because the compiled Python code will be there.
No, so they leave it in the environment, everything in the environment is built in, and your code is inside. The only moving part is the /temp directory where you can write data into that. But again, it will be persistent between invocations unless you deleted it, or unless enough time has passed for it to die, to terminate completely, gracefully.
Yeah, thank you.
No problem.
Excellent. Well, thank you very much, Tal. Any other questions before we wrap and let Tal get some sleep?
I got another one if I'm not stepping on anybody's feet.
Go right ahead.
In the example with stealing API keys from the environment,
Yeah.
I have very limited experience here, but what I have done is have the functions operate based on a role that's applied directly to the function, not credentials I fed in. Does that protect me from that kind of a situation, or does that still
No,
happen?
so for serverless functions, it's always a role that defines the credentials of the function. So when you execute the code, the roles that you defined is translated by the cloud to credentials, right? So you said I have a role. The role is named function a role, and it allows me to write data into my database. When the code runs, AWS translates this into credentials and puts these credentials in the environment. So when the function runs and needs to do what to write into the database, it will use those credentials, and AWS will be able to verify those.
So is this environmentals that you explicitly put in when you invoke the
No,
function,
they
or
are
this is
in by
AWS does
default,
it?
so there is nothing you
Ah,
can do about it.
I had no
There
idea
is
that would be
nothing
there.
you can do about it. They're gonna be there because your code needs it, and this is how it works. And
That's not the case in a EC2 environment, though, is it?
so in the EC2 environment, there is a metadata service. This is the capital one hack. There is a metadata service available on an IP, local IP address, something, and you can ask for the credentials by calling this service, this API. So
I
it's a
see.
little bit different.
And do all of the things that need to do work within Amazon ultimately under the covers wind up calling that API and fetching those credentials? Like if I'm running Terraform at Amazon, or if I'm calling the AWS CLI at Amazon.
So there is no metadata service in a Lambda. If
Yeah,
that's
I
what
understand
you're
that.
asking.
No, I'm asking ultimately in EC2 when I run some code that does work. I haven't populated the environment, but is Boto 3 fetching those credentials and using them? Like they're still accessible to me.
Yes. So
I see.
So Boto 3 will eventually send an HTTP request to
But
AWS.
specifically to request credentials, and then it will use those credentials for subsequent requests.
So it depends. If you run the Boto 3 from the code, then those credentials are already in the environment. So it knows where to take them from. So if you're running inside your cloud account, and if you're running from your computer, then you'll have to provide the keys for the Boto 3. It's not connecting to the metadata service. It needs to get explicit keys, Boto 3 specifically, or AWS SDK if it's a node environment.
Awesome, thank you.
No problem.
Excellent.
Okay.
Well, if nobody has anything else, thank you very much, Tal. Appreciate you staying up late to do this talk. It was very informative, very helpful, and very detailed. So I appreciate that. And you can see in some of the chat, it was well received by others as well. I don't see any questions in the chat. So with that, I imagine we'll call it quits for now, and stay tuned for details on the February meeting, folks. Thank you very much. Have a great night.
Thanks, everyone.
Bye.
Bye-bye.